What is going on, geometry students? Hope you had a wonderful weekend. If you're A period watching this, this is round two for you guys, your second screencast. Sorry I haven't been able to bend it in for you guys, but we will be hanging out Tuesday again and kind of reflecting on this stuff. If you are period E, this is your first screencast for you. Pretty simple. You just follow along. Whenever you need to pause, I'll kind of tell you when you need to pause. But if at any point you need to pause, rewind. The cool thing with this is you kind of get to follow along at your own speed. So you should have done some stuff before we watched this. You should have done that top box, the top two boxes. If you didn't yet, please go back to this wonderful green worksheet that the sub gave you and go ahead and do that before we get started. If not, we're going to dive right in. This is just some quick review of last time. So we're just going to go over the formulas. A parallelogram is just base times height. So that's a square, that's a rectangular. Just do base times height. Triangle, we add that lovely 1/2 in because we're doing half of a square. So half times base times height. Excuse me. And then a trapezoid, we got 1/2 height times b1 plus b2. And we're going to talk a lot about trapezoid and rhombus for the first few minutes of this video. We're going to talk about how they were discovered and what they really come from, how they were created. And then a kite is 1/2 diagonal 1 times diagonal 2. Again, we're going to spend some time talking and dive a little bit more in depth. But just like the homework you guys had, we're going to look at finding the areas of some figures. The nice thing with these ones is, and I really like about it, is because you kind of have to problem solve how to go about solving this. It's made up of some normal polygons that we know, but sometimes you have to take the full thing and subtract parts of it or just add up all the parts. So let's just look at the first one. I'm actually in this screencast going to try to type a little bit more, so it'll be a little bit easier for you guys to see. So what I did for this is I first did 14 times 14. And why I did that is because I took this whole square. I created a big square. Now I can find this triangle and then subtract it from the square and get these two triangles. So this triangle is 14 times 14 times 0.5 or 1/2, which is 98. So now that I have the whole thing and this triangle here, I can subtract that triangle away. 196 minus 98, which just gives me 98 feet squared. This caret means a squared, not cubed, squared. So I thought that one was pretty easy. You just had to think about, maybe it might have took you a while to think to make a square and then subtract that part of it. If you didn't do that and you tried something else, it's a good try. You always, these things just come from practice and just sometimes sitting a little bit longer in problem solving. Sorry, I had to make another screencast for my algebra class, so my voice is a little bit gone. This one, you can see how I broke it up into rectangle, rectangle, triangle. This rectangle here is the easiest one, just 6.5 times 5, which is 32.5. Multiply them together, base times height. Now this next rectangle is a little bit more difficult. You have to do not 16 times 5, but you have to, in 5, how I know this is 5 is just because it's the same length, this part up here. You actually have to do 16 minus 6.5, which is 9.5 times 5. So 9.5 times 5 gives you 47.5. And again, if I'm talking too fast, you miss anything, just rewind, hit pause, do what you got to do to make sure you're following along and filling in what you missed. Last but not least is this triangle. This triangle is actually going to be, the base is 9, the height again is 9.5, and then we have to multiply by 1/2. So we're doing 9 times 9.5 times 1/2, which is 42.75. Now once you got all these, you take out your calculator or your phone, like I'm going to do. I'm going to take out my phone, add them all up. 42.75 plus 32.5 plus 47.5 gives you 122.75. 122.75. And don't forget your units. It's meters. Get me out of the way. Ooh, I'm flying up there. Meters squared. Not too bad, not too bad. So, next thing we're going to look at, like I said, I'll come back down to the right corner where I belong. We'll zoom out. Come on, zoom out. There we go. We're going to look a little bit into the trapezoid and the kite formula. So I want you guys to pause the video right now and think about what we did last class and how we manipulated the trapezoid to look like a parallelogram and a square, and kind of do the same thing with a kite. And think about the main thing is we want to somehow manipulate the what am I saying right now? Manipulate the shapes to look like parallelograms, because then we could just apply the base times height formula. So go ahead, pause the video, think about that, and get ready to write stuff down in your next two spots. Alrighty, let's look at the trapezoid first. So I'm actually going to show you this YouTube video. So the trapezoid we were trying to find the area of is this 8, 10, 6 height, 6 centimeter height trapezoid. Now what this person does in the YouTube video is they duplicate the trapezoid, rotate it, and then connect it so it forms a parallelogram. Remember, a parallelogram is just base times height. So it's just base times height. But look, now our base is 18 when it originally was 10. But look at base 1 plus base 2 gives me 18. So base 1 plus base 2 times height. Now, this will give us a whole parallelogram, but we don't want this whole parallelogram. We only want half of it, because half of it gives us back to our trapezoid. So that's why we do 1/2. Look, that's what she's saying right now. Hold on. And divided by 2. Look at that. Pretty interesting. So the cool thing is we just took a trapezoid, turned it into 2 trapezoids, formed a parallelogram, and then just apply the parallelogram formula and got our trapezoid formula. So again, write anything you want in that thing for trapezoid box, whatever will help you remember that. You can always go back and find this YouTube video. Now let's look at the kite. Kite is kind of the same thing. So this person, remember, it's diagonal 1 times diagonal 2 times 1/2. So here's our diagonal 1, 14. Our diagonal 2 is this 8 right here across. So what this person is going to do, they're going to take this red part and move it down here, and this blue part move down here, and form a nice little parallelogram or rectangle. Oh, look at them go. Cool. So now we have a rectangle that's 14 by something. Well, this is not by 8 anymore. This is actually by 4. Well, remember, 4 is half of this diagonal. So diagonal 1 times diagonal 2. But now we don't have the full diagonal, we only have half of it. So 14 times 4. So 1/2 diagonal 1 times diagonal 2. So I just thought that was pretty cool where that formula came from. So again, you need to pause, rewind, check out what happens, make sure you jot something down, and we can move on to the application part. I'm going to do the first application with you, then you're going to do the other 2 on your own. I'll quickly go over the answers, and then you will be on your own to start working on the homework / classwork. That's just one worksheet, front and back. It'll be due next class. So this one, we got your lawn's a little messed up after the winter. You need to get some turf builder to fill in some area. The nice thing with this is your lawn's a nice square. Sometimes that happens, like you live in New York City, nice square. I mean rectangle. But you live out here in Mansfield, Ashford, a lot of times it isn't. But for this application, we'll pretend it's a rectangle. So first things first, let's find the big one. We do 150 times our 145. Plug that into calculator. 150 times 145 is 2,175. Now we have the big pot. We can break out these little, I think this is your house, maybe this is your walkway. We can take this out and figure out the whole thing. So I'm going to form rectangles. This rectangle here, well, it's just 20 times 34, which is 680. Again, I'm going to get out my typing tool. This is 680 up here. What I mean by up here, it's this part right here. This one's going to be 20 times 40, which is just 800. Rectangles are super easy to deal with because it's just base times height. Now we need to figure out this black part, this little walkway. Well, we got 60 for the height, but what's the base? The base is actually 20. And how I know that is because this whole part up here is 60. And this whole part down here is 60. 60 minus 40 is just 20. So 20 times 60 gives me 1,200. 1,200. So now I can add all those up and get 2,680. Subtract the two of them. So we're going to subtract the total minus what we're taking out. We can do that over here. Come on. 2,175 minus our 2,680. Hold on, I think we did something wrong. Oh, this I forgot a 0. Silly me. 0 here. Because that would have given us a negative number. See, math, logic helps you figure things out, your mistakes. So we subtract 2,680 from that, we get 19,0770. So that's how much area we need to fill. That's how many square feet we need to fill with Turf Builder. Now, the Turf Builder covers that much. One bag covers that much. So we can do 19,070 divided by, that will tell us how many bags we need to purchase. We need to divide about 19.61. So if it's 19.61, we're going to need 10. We need 10 bags. So this is 9.61. So we need 10. Well, each bag's 24.98. So 24.98 times 10 is going to cost us 249.80. That's how much it's going to cost us. $249.80 to fill our lawn, to do our lawn. And believe it or not, that's actually kind of realistic if your lawn's that big, because turf is wicked expensive. Wicked expensive. So what I want you to do now, it says your turn. Try 2 practice problems on the back of your worksheet. You only have 2. It's examples 2 and 3. I want you to do that. One of them says Katie's room, which is this one. You're going to have to draw something for that. Example 3 is going to be this one. Come check back in. I'll show you the answers, and then you will be all set to go work on the worksheet. Alright, so you should have took some time to try the paint problem and the state park problem with the sealant of the deck. So when it comes to Katie's room, you need to paint 4 walls and you need to paint the ceiling. So you should have figured out the area of 2 walls on the square, the 2 other walls on the square, and the area of the ceiling. So you should have got 220, which is 2 of the walls, 264, which is the 2 other walls, plus your ceiling, which was 12 by 10, plus 120. That would give you 604. So the walls, painting the walls and the ceiling, that's 604. That's you're looking at feet. So then you divided that by 150. And that just gave you roughly 4 cans. Then you would have done 4 times your 15.99. So that gives you 63.96. That's your final answer. That's in dollars. That's how much it would cost her. About $64. This one, you just found the area of the deck, which is using the diagonal 1 times